So we know how to make the motor go forwards. How do we make it go backwards? Well, having the motor go forwards, we need pin 12 to be on and pin 8 to be off. Pin 12 is high and pin 8 is low. To make it go backwards, it's the other way around. We can put a 0 here and a 1 here. Now, I could write my code like this. I could copy this to, this is going forwards, and then paste it here and change it, and this will be going backwards. And then if I wanted to go forwards again, then I can say this. And then if I wanted to wait, I could put in code to wait, and so on and so on. But that will get very, very repetitive if you're doing lots of robotic motion. So we can write a function to make it easier. This code here, these two lines, make the motor go forwards. So let's put these in a function. We'll define a function, create a function called motor forwards. Excellent. It is showing an error with this line here. It's expecting an indented block. When it says indented, it means these two lines should be inside this function. We want these to be part of the function. So to do that, you can go at the start here and press tab and do the same down here. There we go. So that will put 4 spaces there and show that these are inside that function. Now this won't actually run. And sure enough, if you download this to your microbit, even if you press play, nothing actually happens. If you download it to your microbit, nothing will happen because we haven't run the function. We've defined a function, just like we can define a function called motor backwards. I can copy this, go down here, and make a new function called motor backwards, and that will have pin 12 being off and pin 8 being on. And even though I've got these two functions defined, if I press play, nothing seems to happen. How sad, how sad. What we can do though is we can call the function. So I can say, let's make the motor go forwards. So when this program starts, it'll define these two functions, but it won't run them just yet. And then at the very end, it'll run these two lines of code. It'll run the motor forwards function. You can see that pin 12 is on and pin 0 is off. To make it easier to use the simulator, if you don't have a microbit handy, you can do print forwards in here and then print backwards in here. That is handy because now when you run it, you can show the console and it will tell you what the motor's doing. The motor's going forwards. Did you notice that even though I defined this function here, it doesn't run this code? Not yet. It'll only run it if I run that function. And that's handy because then I can write very readable code like make the motor go forwards, and then let's go basic and put a pause in for, I don't know, half a second, 500 milliseconds, and then make the motor go backwards, and then do a pause for 500 milliseconds again. If I press play, you can sort of see it in the simulator, but it's easier to see in the console. It made the motor go forwards and made the motor go backwards, and then the program ends. You can then download this to your microbit, and you should see your motor spinning forwards for half a second, and then spinning backwards for half a second, and then forwards for half a second, backwards. Wait a minute, no, it only runs once. It goes forwards for half a second, and then backwards, moves backwards, waits half a second, and then ends. And so it's still stuck going backwards. Because the last thing we did was set pin 8 to 1 and pin 12 to 0, and it's still just stuck like that. So if you want to stop the motor, then you can set them both to 0. You might remember, if we set both of these pins to 0, then the motor doesn't move. So let's make a new function, def motor stop, and this will write pin 12 and set it to 0, and I'll copy that and paste it here, and pin 8 also 0. So then at the very end, I can say motor stop. To make it easier to debug on a computer, you can do print motor stop here. And if I run, it should go forwards and then backwards and then stop. Shows that in the simulator, and you can sort of see it up here, lighting up the correct pins. Okay, so if you download this to your microbit with your motor connected, then you'll see it go forwards for a little bit and then backwards for a little bit and then just stop. One last thing that we will do, if you want to do this forever and keep going forwards, then backwards, then stop, then forwards, then backwards, then stop, then forwards, then backwards, then stop, you can chuck this in a loop. If you go to basic and go run code forever, then I can put these lines here inside this function. So this makes a new function called onForever, and this function gets called over and over and over and over again. Now, you may notice that this one here doesn't actually seem to stop the motor. How interesting. And sure enough, if you have a look at that in what your microbit is doing, if you download it to your microbit, then you will see that it doesn't really seem to stop. It just goes forwards and then backwards, but doesn't actually stop in the middle. And the reason is we've said, set the motor going forwards, wait a little bit so we can see it going forwards, then set it going backwards, and then wait a little bit so we can see it going backwards, stop the motor, and then immediately go move the motor forwards again. It doesn't actually spend any time at all with the motor stop. So let's pause the program, for a little bit so we can see the motor being stopped. We'll make this a little bit longer just so we can see, and I'll download this to the microbit as well so we can see it on the simulator and what the program actually does. So it goes forwards, waits forwards, backwards, stop for 2 seconds. Cool. And that, my friends, is how you can control a motor using the microbit. Cool. I will see you guys next time. Have fun making and creating. Bye.